In case of doubly reinforced beam, you are using reinforcement in both the levels, that means at the bottom level and at the top level. And in one portion it will be acting as a tensile reinforcement, it will be taking care of the tension, and in other side it will be taking compression into account. So that means reinforcement will be used as a to take care of tension as well as compression. So it will be known as tensile reinforcement and compressive reinforcement. Then beams with side face reinforcement. As we switch over from singly reinforced beam to doubly reinforced beam, whenever there is restriction of the depth of the beam, and if still after putting all the design parameter or into consideration, if still the depth of the beam is larger than 750 mm, so as per Indian standard code we have to provide side face reinforcement. So later on we will be able to design the beams with side face reinforcement. Then curved shape beams, that means their shape is curved, not linear shape, they are curved shape, and these type of beams you will be designing in case of water reservoirs, that means water tanks or any other application. Now how we will differentiate it? That R.C.C beams based on bending moment diagram, that means if different type of beams have different type of bending moment diagrams. Now if you are talking about simply supported beam, then you can be very much aware. Now in this figure or in this diagram you will be able to see a beam which is uniformly loaded and simply supported at both the ends. The span of beam is L and load is WL. Total load will be WL. So correspondingly, if the simply supported beam is subjected to UDL, then you are aware that this first diagram will be the shear force diagram. That means shear force will be 0 at the center and maximum at the supports. So supports are more critical in case of shear. And if you see the bending moment diagram, now if I can show you. Now this is the bending moment diagram. So you can easily visualize here that maximum bending moment is at the middle of the span and zero bending moment at the supports. So that means maximum bending moment you will be getting at the middle of the support, so which it will require reinforcement. So this is the simple support beam. And in second case you can talk about the cantilever beam. If there is a cantilever beam case, then this end is fixed end and this one end is free end, and the UDL load is in the form of UDL. Generally load on the beam is in the form of UDL. Now here you can say this is the shear force diagram. So shear force is maximum at the end support and 0 at the free end. And when we talk about the movement diagram, that means bending moment diagram, so you will be looking that this bending moment diagram is a curve shape. It is a curve shape and maximum bending moment is at the support, that means end support, fixed end support, and then it is consistently decreasing to 0 at the free end. Now third one you can say it is a fixed end beam. Now fixed end beam, now in this case there is a beam which is having fixed end at both the ends. Now this is a fixed end, this is a fixed end, that means movement is 100% restricted, it is expected. Now this is span of the beam and it is loaded uniformly. Now if you see shear force diagram in this case as well as in this case, that means in simply supported beam and fixed end beam, you will be able to see that shear force diagram is almost similar, or you can say it is similar. So there is no variation in the shear force effect. But if you see here, that is bending moment diagram. Now bending moment diagram you will be able to see that it is maximum positive bending moment diagram, and maximum positive bending moment diagram you will be able to see that is at the mid of the span, and then bending moment will be decreasing and it will be changing its sign and becoming negative at the support. So that means at support bending moment diagram will be negative. So this bending moment is negative, this bending moment is negative. So that means if you can say there is maximum positive bending moment as well as some maximum negative bending moment. So whenever we are talking about the fixed end beams, so you have your design parameter will be different from simply spotted. Now you can see here in simply spotted at the end bending moment is 0, but in case of fixed end bending moment is not 0, it is negative. So whenever you design, that means if here bending moment is positive at middle, now what will be the behavior of the beam? Beam will be bending downward. So that means tension will be at the bottom. So at the middle portion tension will be at the bottom, but at the end support tension may be upward. So reinforcement pattern, installation of reinforcement or that will totally change. Now our concern is continuous beam. So in structure analysis subject you can understand or you can able to draw shear force and bending diagram for different type of continuous beams. So here I am just showing for the reference purpose continuous beam to equal span. Now you can see this is a continuous beam having more than two supports. So these supports may be simple support or any type of supports. Now again continuous beam can differ in the form of the span length. Now if you see here both the spans are of equal length. They can be of different. So it hardly matter when the span length changes, then bending moment diagram will change. Now here you can able to see that only left side of the span is loaded and the right side of span is not loaded only. That means this portion of the beam may have to design for only self weight or minimum load. Now if this diagram we take into account in the left portion, that means left span, and this is the right span, because there are two spans we can say, one is left span, another is the right span. Otherwise there will be end span, intermediate span, etc. Exterior span, interior span, like that will be differentiated. Now here this will be the shear force diagram in case of if they are two equal span, only one span is loaded. And when one span is loaded, it is just like a simply supported beam. So you will be able to see the bending diagram. But because it is a continuous support, bending diagram changes here. So this is positive bending diagram. Here it is negative, and here it is negative. So bending diagram you have to take into consideration. This is very important. From bending diagram, you will be able to find out what will be the maximum positive bending moment and maximum negative bending moment. Accordingly, you have to design the continuous beam. Now continuous beam when two equal span and this another type of when load changes. Now loading pattern we have changed. In the first case there was UDL, and in the second case we are putting a concentrated load. So accordingly, why I am showing you these pictures, these diagrams, because I want to just focus on that whenever you change the loading pattern, then shear force diagram will change as well as bending moment diagram will change. And when you have to design the beam, suppose you want to design in this left span or right span, then accordingly you have to pick the value of the maximum positive bending moment as well as maximum negative bending moment, and accordingly we will be able to design the beam. Now very important features which we have studied in the previous class also, that means what are the basic guidelines as per Indian standard 456 version 2000. So very first is flexural reinforcement, because you are aware whenever we are designing R.C.C beam, we are designing R.C.C beam for flexure, that means bending. It is expected that beam will bend when the load is applicable on it, whether it is concentrated load or UDL load. Now how IS 456 is taking care of all these parameters. So very important parameter is concrete cover. Now why concrete cover? Why you are covering the reinforcement with concrete? So basic purpose is durability. Because if your steel is exposed to weathering agents, that means steel is exposed, then weathering effects like there may be air, there may be moisture, etc. Depending upon the type of the structure, whether structure is a C structure or whether it is a simply house or any column, beam, slab, etc. So cover is the most important requirement for the purpose of durability. And for this, you have to refer this clause, that is clause number 26.4.1, and you have to refer a table number 16, which is given in IS code. Now what is the purpose of the cover? Safety against weathering agents depending upon exposure condition. Now code is defining different type of exposure condition in table number 5. Depending upon the exposure condition, whether it is a mild exposure condition, severe, etc. So there are 5 type of exposure condition. Depending upon exposure conditions, your steel, you will decide how prone is your steel to corrosion or these effect. And depending upon all the exposure condition, you have to decide the minimum concrete cover required for the reinforcement. Now this table number 16 is given in IS 456. Now if you go through this table, that means it is the nominal cover, minimum cover required to meet durability requirement. Because durability is directly related to the life of the structure. And whenever we are designing a R.C.C structure, generally we design it for a lifespan of 50 years or maybe more than 50 years. Now how it will behave, what will be its actual life when it is subjected to weathering effects and under use, then how much is it will be durable, how much its durability, its life, how long it will remain in its actual position. So that depends upon durability. And durability, to take care of durability, very first step is to take care by using nominal cover. So code is here suggesting through table number 16 that minimum cover required depending upon the weathering conditions, that means exposure condition. Now see, you see here there are different type of exposures, and nominal concrete cover in millimeter not less than, that means you can go beyond this, but you should not provide cover less than all these table guidelines. Now if it is a mild area, that means your weather condition are mild condition, very normal condition, no pollution or minimum pollution, temperature variation are normal, so then you can go for 20 mm minimum cover, or 25 mm. You can go beyond 20, but minimum is 20 as restricted by code. If it is a moderate condition, you can go through Google and you can understand that which type of structures will come under moderate condition. Now if we talk about the severe condition, suppose there is a C structure, suppose there are jetties. So jetty, they are consistently or continuously or throughout their life, they will remain in sea water. And we are very much aware, everybody knows that sea water contains lot of salts. So lot of salts are there. So these salt can affect the structure. So in case of severe type of structure, 45 mm minimum cover is required. Very severe, 50 mm, and extreme 75. That means you have to first of all distinguish that which is the structure which you are going to design, and whether that structure is prone to mild conditions, moderate conditions, severe, very severe, or extreme conditions. Suppose you are going to construct a building, or a building just like a factory, chemical factory, where environment in the factory environment, there will be always prone to chemical effects. So chemicals are there, though that means that chemicals are manufactured, the chemical are expected to be in air, and when they are in the environment, they will be affecting the structure. Now, very first step is, if you use a cover, specified cover to the reinforcement, then other factors are also considerable. But before that, we can assure that if reinforcement is given sufficient cover, so that, and not only cover, type of concrete, density of concrete, grade of concrete, all these parameters directly affect the durability, permeability affect the durability, porosity affect the durability, etc., water absorption value. But all those values directly related to the cover. So that means if you can control the cover, you can control the durability of the structure. And other few notes are there. That means if you want to, if depending upon the diameter of the bar, actual conditions, you can reduce or increase the cover. Now again, other parameter, that is spacing between steel bars. Now when you are putting steel bars, whether it is in a slab or in a beam or in a column, then you have to, as per code, now code is restricting some spacing between the bars. And why it is specifying the spacing? Because it controls the area of the reinforcement, that means minimum and maximum. So code is restricting minimum steel area and maximum steel area. One of the main purpose is smooth placing of the concrete, because if the spacing between the steel bar is very much less, then it will be very difficult to concrete. That means pouring of concrete, settling of concrete, all these things will be very difficult. So for smooth placing of the concrete, you need spacing between the bars, and that is what let us see what is suggested by this clause number 26.3.2. Now minimum limit between the reinforcing bar is specified. Purpose very much clear: to ensure the smooth placing of concrete between and around the steel bars. Then maximum limit is also specified for the purpose of controlling crack width and improving the bond. Later on you will be able to understand that if you use higher spacing, then cracks may develop. So to restrict all these crack width, because we are very much aware that in case of concrete is never crack free material. There are always cracks, micro cracks, macro cracks, but whether those cracks are dangerous, or depending upon the crack width, you will decide whether those cracks are acceptable or not. Because some of the cracks are structural cracks, some of the cracks are only surface cracks. Now, flexural reinforcement requirement, you have to go through the clause number 26.5. This clause basically gives the guidelines which will control the area of reinforcement. Now in our case, we have to design beams, so our emphasis on beams. Now in beam, as already we have discussed, there may be tension reinforcement as well as compression reinforcement. So as per code, clause number 26.5.1.1, that clause define guidelines regarding the tensile reinforcement. So minimum area of the reinforcement you have to calculate according to this formula, which you have already studied in case of slabs, as design of slab, design of beam, singly reinforced, doubly reinforced, etc. So this is the limit minimum area of steel required. And another clause, again it states that the maximum area of tension reinforcement should not exceed 0.04, that means 4% of gross cross section area of the beam. Gross cross section area mean overall depth multiplied by the width of the beam section, and you need to calculate the 4% of this gross area, and this will be the maximum steel. So code is restricting minimum area of steel as well as maximum area of steel, because if you go beyond the maximum area of steel, if you provide more than 4%, that means you are providing 5%, 6%. So it may happen that your structural member may be over reinforced. So for compression reinforcement, you have to refer the clause number 26.5.1.2. So here it is mentioned that the maximum area of compression reinforcement shall not exceed 0.4% of BT. So here these are the basic restrictions. Now another important aspect is about the transverse reinforcement. That means shear reinforcement basically. Now here you will be able to see very first transverse reinforcement for shear and torsion. Transverse reinforcement in beam shall be taken around the outermost tension and compression bar. You have to put the tension bar or compression bar, and you have to surround it by stirrups. That stirrups may be of any types. So those type of stirrups are known as transverse reinforcement. And for that you have to refer various clauses 26.5, 1.4 to 1.8. So all these clauses will advise you guidelines regarding control of shear and torsion. Controlled by restricting the how code is controlling all these shear stirrups. Basically, when you design shear stirrups, you will design the spacing between the shear stirrups. So if you increase the spacing between the shear stirrups, definitely area of the shear reinforcement will decrease. And when you are putting shear stirrups in close association, so that means number of stirrups will be more, area of transverse reinforcement will automatically increase. Now in case of beams, we are talking about beams. Here code is restricting maximum spacing, not minimum spacing, maximum spacing, clause number 26.5.1.5. So maximum spacing for vertical stirrups, if you are using vertical stirrups, then maximum spacing should be less than or equal to 0.75 effective depth of the section. And maximum spacing in case of inclined stirrups, which are at 45 degree inclination, then maximum spacing is equal to maximum effective depth of the section. But another condition is when you calculate these type of spacing, in no case it should be beyond 300 mm. So maximum limit of the stirrups spacing, transverse reinforcement spacing is 300 mm. Now minimum shear reinforcement, here code is restricting what should be the minimum shear reinforcement. So clause number 1.6, 26.5 and 1.6, minimum shear reinforcement is provided as per these guidelines. You can go through all the guidelines of the Indian Standard Code. Prominent or basic guidelines I have already discussed. So because all these guidelines will be very much helpful in case of design of any type of beam, whether it is a simple support beam or whether it is a multi-span continuous beam. Now another aspect is, as we have to control the flexural rigidity of the flexural member. Now beam is a flexural member, that means it is subjected to bending. Bending is known as flexure. So flexure rigidity means how rigid your structure is to resist the flexural effect of the loads on the member. Now here, as per IS code is restricting or controlling the flexural rigidity by controlling deflection. Now deflection control as per IS 4. How IS 456 gives you guidelines to control the flexural rigidity. By controlling, or you can say by limiting deflection, the flexure rigidity, that is bending behavior of structural member, can be controlled. That means if you want to control the flexure rigidity, then as per code, you have to limit the deflection. That means how much deflection is allowed. Second, cross-sectional dimension of the beam for a particular span can be controlled and designed. Now how? In clause number 23.2, if you see, code is restricting all these guidelines based on span to effective depth ratio. Span to effective depth ratio. Very first point is the final deflection due to all loads, including the effect of temperature, creep, shrinkage, and measured from the as cast level of the support of floor, roofs, and all other horizontal member, should not exceed. That means the final total deflection due to all these type of effects should not exceed a value that can be obtained by dividing span length by 250. And second, deflection including the effect of temperature, creep, shrinkage. This in second point I am talking, occurring after erection of partition. That means after installation of the member, then maximum deflection when you have applied all the finishes should not normally exceed span by 350 or 20 mm, whichever is less. So two type of deflection criteria are given by code. These are the maximum deflection, final deflection, or you can say maximum deflection due to all the parameters. Now 23.2.1a, in this clause you will be able to see that the value of effective span by effective depth ratio, but condition is when span is up to 10 meter. So these guideline we have already studied in the previous class also. That means for cantilever type of beam it is 7, for simply supported beam it is 20, for continuous beam it is 26. So if we follow all these guidelines, then it is expected or almost sure that your structure is very good in flexural rigidity.